Let's go ahead and get started. I have all the things that I want to do today. The first is just finish a few of these slides. I don't think it'll take too long, because the very last item on our study guide was blocks, and we haven't really got the chance to talk about that. And the second big item is I want to get questions from anyone with regards to the quiz that is now on Monday.
Okay.
Even though always working.
You just quit.
It's an
Tomorrow's the
undefined,
last day.
it's undefined
I
behavior.
guess I could make that announcement too, right? Tomorrow is the last day to withdraw.
Good to know.
If you're considering that, please come talk to me first. I'm not saying that I will
I'm in
100% tell you you can't withdraw from my, but I at least want to have a discussion about if it's something you're considering, let me give you a realistic view of where your grade is right now and what to expect moving forward in the class, so that you can make an informed decision with as full knowledge as you can from my perspective.
I know what you're talking
I'm programming a logic bomb into the group's project and then withdrawing.
All right, so do we care about the order in which we do those things? There's one last item, the stubs versus mocks, as well as a few last slides here. We want to cover that material. Do people have questions from anything from the study guide and anything they would like to go over in more detail, have me explain again in a different way?
So I have only one. So the testing, black box versus white box.
Yeah,
So white box was kind of, you look at the code and you discover the error. So the black box was after the integration system testing and all those things was part of the black box testing.
yeah, imagine you don't have access to the code. So either you're an end user, just looking at the usability of the program. As I type things, can I make it break? You don't need access to the code to be able to provide an error report on, this is the sequence of what I did, here is what the result was. And then you pass that back to the programmers to say, go fix these issues. But yeah, black box testing just has no code associated with it. End user testing, or just using the complete full application without looking at the code. White box testing are the kinds of tests that you actually write using code to discover bugs in the code, or a situation that's not right from the code's perspective. So unit tests are white box, integration tests are white box, but when you get to things like acceptance testing, that is black box. Because that's the end user saying yes or no, this involves everything that I needed it to involve. As I try to use it, it breaks in this important way. So they have no understanding of the code.
Why default?
No, I think it just has to do with a black box. A black box is an unknown system. So
That's the idea of where you're testing it from, where you're inside the box, you know what's going on. So you test.
the white box, there's light in the box, so you can look inside the box and say, oh, I understand the contents of the box. For the black box, the light is off in the box. You can't determine at all what's happening inside the box, because you can't see inside of it. At least that's how I think of it. Light on, light off on the code.
What if it's like the light from Invincible, where if the light's on, you can't see it?
Whoa. Whoa. And this is how computer scientists get themselves confused over the simplest of functions.
It's like how they call a pull request for when you want to push code.
You want to merge code? Yeah, it's a
Yeah.
very confusing term.
Say push to branch.
A merge request would take much.
Thank you.
Come back with the word update.
All right, any other preferences on questions for now versus slides for now? Anyone else have any questions that you would like to have answered right away? If not, I can go over some slides, we can think about the questions that we have, and I'll come back to that after the slides. All right, let's do that. Last we were talking about the challenges of integration testing. So how many ways can we test a partial system? And we were motivating the use of selection blocks. So in this project, as well as in industry, you will be interfacing with a system that is not yet complete. Whether that's someone else is working on those components, Whether that is, you're eventually gonna be working on those components, you can't fully test the piece that you've written until those other pieces are complete. But if you're waiting for those pieces to be complete, you can still test some functionality by making dummy objects or dummy methods, dummy behavior that returns something very simple that allows you to further test how your system handles these kinds of interactions. Even though it's not a complete object, it doesn't have all of that functionality, what can we put in its place in order to fully be able to test this component? So we're gonna go over stubs and mocks. The first is a stub. It's just some kind of controllable replacement that has some test under some dependency. So things like a network connection, you can make a stub that says connection refused, and that is the immediate response, that there's no logic behind it. Whenever you query the stub just responds with the message connection refused. And this allows you to test what happens in my system when I get that signal. You're kind of hard coding that, but within the interface of the system, you're still gonna send the request. You're still going to get a response. It's just from a stub that is, it has one functionality, and that is to return connection refused. Or a database, failed to find. Or even if you have a stub that is a single response from that database, you want to return a legal object, so you're going to hard code a legal object. And rather than actually hard coding it in the system, you're still going to use all of the correct communication methods within your code. You're going to make a request, but that request is going to come back with a hard coded database entry. So step one to making a stub, what is the dependency? What is the thing that you need the other class, the other object, the other piece of this other module to return to you? So identify what that dependency is. So it's likely either going to be a resource or it's going to be an object. It's going to be something that isn't implemented yet. If it isn't an object, you will want to wrap it into one. So for instance, let's say that we're looking for some kind of HTTP response. Usually that is an object, but let's say you're just trying to get that particular value. If you care about that value, wrap it up in a dummy object where that is the only field, where the only method is to return the value of that field. Very simple object, does no functionality that matters, except it allows you to communicate and get that exact response. You can also use it as kind of a middleman, like this is. So let's say we have this resource X that we need to be able to use, and all we are trying to do is interface with X, test A's interface with X in some small capacity. We're gonna write class B that is going to just do some basic stuff there that allows us to do that. We're going to write this interface that allows us to stub in and say, great, now we can interface with this, have A work with this interface, B is a part of that, so then you can write a stub for that now does what B does for the scope of this. Right, so instead of the real data here, the actual, let's say this is the database, it's gonna return actual data. And we either don't have this or want to simulate it. Or it's currently broken and you want to make sure, is it broken here or is it broken here? Is the communication broken? Or is the actual data broken? Where is the issue here? So we can stub in something that has some hard-coded fake data and use this same interface rather than going through this brittle legacy something code or something that's not done yet. This is going to be, it's going to simulate this process before this process is complete. Or to identify an issue with this process. Does that make sense? Any questions on that? We're emulating this behavior with fake data.
So, in
Yeah.
that situation, when we test it with the real, object or with the real data, then in that situation, refactoring will happen to change the names and all those things, but the method inside that should work exactly how it is.
Yeah, the only change that should be here is you're replacing the stub with the real connection once that's there. But this is to test all of this. What happens when we request this data? If this isn't made yet, then, or this isn't available yet, or this data hasn't been collected yet, and we want to make sure that we can interface with that kind of data and find errors associated with the code in this process, we can find those errors before we connect it to the real resource. That also is very important for things like security concerns, where you can identify there's a big security concern here. If you connect it to the real resource, maybe this real resource is social security numbers. If there's a security vulnerability in your code, you would rather have identify an attack on fake data than identify an attack on the yummy data. So you can do all sorts of testing with stubs before you replace it with the real connection to the real. And there are tons of reasons why you might want to do that. Security reasons. This isn't complete yet, the code is still in development. Any of that would be, we can test all of this before this is done. And we've seen already in this project just how many things can be happening concurrently. And if you want to be testing your component before what someone else has is done, then you want to be able to just have this idea of a stub. You can write a stub for what they're doing and test your code and make sure that it's working to your standards before they are done with their code. So you're going to be making these stubs at what we're going to call seams, places in your code where that communication is done. So now when we make A, the constructor for A is defined by this interface, kind of, we do this, and the interface for B is gonna be what we use to interface with it. So we can now add the constructor to the stub inside of whenever we make the A object. When we make A, instead of a method that uses B, this is gonna be a method that uses a stub of B because it's OOP through the interface. We're actually using polymorphism to say that you can go through either B or stub B. And when we make this A object, we decide what it connects to. Does it connect to the real object through B, or does it connect to the fake object through stub B? So we just instantiate the stub B here to show that we're going to connect to the fake data first. Really important concept. Any questions on stubs? Think of it like a single behavior that you're trying to emulate with a hard-coded value. This is the same as if you wanted to do something like go into your code and hard code that object. Don't hard code the object in the actual source. You can stop doing that now. It's bad. It's bad. You don't want to do it. You would rather make a stub for it, and that way you're not modifying your code. You're not doing something that you have to undo later. You're creating an interface that allows you to plug and play test objects. Where when you're ready to plug in the real thing, you just unplug the fake object and plug in the real object. No modifications to the source code needs to be done at that point.
So, from one.
Unfortunately, I can't, if I did all of this course's lecture in 1 week. I don't think that would go over too well. So the other important kind of substitutable that you can have is a mock. So a mock is an entire fake object. So now instead of simulating a single behavior, you're going to simulate the entirety of an object. This mock will help you to be able to determine whether a test passes or fails by identifying, okay, what happens as we're doing this communication. So we're gonna write some tests. The class that's being tested is going to assert the tests. The communication is gonna happen with a stub. This is the stub world. In the mock world, the communication happens rather than with a stub, with the mock object, and the mock object is what runs the tests. So this is necessary when you have dependencies. The class needs to do some communication with an object. How much of that can you simulate in that object and have that simulation run the tests? We'll make this significantly clearer over the next couple of slides, just give people a little bit of a chance to write some things down if they'd like to. So the difference. Stub is going to send the data directly to gives out the data that goes to the test. So we are going to be grabbing whatever the stub gives us, that hard-coded object, something of the sort. We're gonna be taking that information and directly from the class under test with that data, pass that along to the test, which is how we get this assertion. We get the information from the stub, and then this class directly calls the tests. The mock, on the other hand, is sitting there with functionality waiting. Now this can be the entirety of an object. It's not trying to just simulate a single behavior. This is a full mock object. So it's going to do things like verify it was contacted in exactly the right way. If the interaction between the object and the mock object is correct, then the test is going to pass. But what decides whether that test passes or not is part of the mock object. We have this concept of was called properly. And so now we can use that directly with the unit test, directly from the mock object to determine based on this property was called properly. And we're looking at now the interface between those objects rather than trying to simulate data. Now we're trying to simulate the behavior between objects without actually having the complete object. Stubs are things that you're going to make by hand usually. On the other hand, if you want to really deal with mock objects, this is not something that's easy to create yourself. So there are plenty of frameworks that you can use to help with this process. So if you're one of those teams in Java, JMock is the kind of standard. I believe it's still the standard. I may be wrong on that. But there are mock frameworks that you can just use to test the framework between objects. What can you do with these kinds of frameworks? You can auto-generate mock objects, so you don't have to write them yourself. You can log what calls are performed, so you can actually see what methods are called within particular data without having to step through your code line by line. You'll actually get a log of that is generated by the framework. Very useful. You can also declare and assert your expectations for a certain code, and it works kind of like unit tests, but they're more temporary unit tests for your framework. Is this framework constructed in a way that will lead to future unit tests passing once this is fully implemented? I wanted to give people a little bit of an example of what this looks like in code. So JMock might produce an object that looks kind of like this. You get some fun syntax, mockery objects. Make a mockery out of your code.
I'm already doing that.
Those of us who do dad jokes, it never goes away. It's never quiet. You're always looking for the next terrible dad joke. If I haven't made someone face palm yet today, I haven't done my job.
Gonna be hard, cause I enjoy dad jokes.
There are some of us, and there are some of us who are just like, please stop, please don't go there. So just code that makes the objects, sets up the mock, calls based on an object called an expectations. To determine, does this actually happen? So we're gonna call it and find an expected parameter, if that's true, then we eventually get that back, and we can do things like assert is satisfied, asserting that the behavior of the connection of these objects as is what was expected according to this expectations object that was created. So it's just a nice framework for this. All of this generation can happen by JMOD. You don't actually have to write this, you just have to specify, here are the expectations, here are the assertions that we need. It will make the object, it will tell you yes or no to those expectations. So it's a lot faster than actually writing and plugging your own mock objects. So some of the syntax, I'm not gonna be testing you on any of this syntax. The only thing I'd be testing you on would be things like, in general, what is a stub? What is a mock? What is the difference between a stub and a mock? Higher level than API calls and JMod, or even what JMod is. It's just an idea of, if you want to include something like this in your projects, it's worth the research to figure out what it is and how it can help you. And also, it's just another term that you've heard as you go into industry, as you go into interviews. If someone says, what's your experience with this? You at least know what it is.
Do you think they'd accept? Yeah, my teacher definitely talks about that at some point. Do you think that they won't like that one?
Let me know how it goes for you. Get back to me on
That is.
So, other stuff here, I will upload these slides, you can go through them in more detail. I don't think it's incredibly relevant for a lecture environment. It's better to just kind of, the more important thing is this next slide, which gives you an idea of, all right, how do we use both of these at the same time? What is the stub and the mock in this process? So we have a log analyzer that's gonna take debug logs, and it's gonna try to figure out, based on what happened, what is the action that needs to happen as a result of that? So, for instance, we try to access a web service. The web service returns some string as an error. Something happened as we attempted to communicate with this web service. It returns a log string. The log analyzer needs to parse this string. And based on what happened, if it's an important issue, automatically send an associated email to someone that says a fix is needed for this, or something happened. So what is the stub and what is the mock? The stub is the web service that intentionally fails. So this is something that is not implemented yet. But we want to make sure that our log analyzer is functioning correctly. So we're going to make a stub for the web service that automatically returns the error that we're expecting, or an error that can be parsed. It's going to be a hard-coded error, not an error that is actually happening. We're not actually making any kind of requests to any real web service. We're just looking to return the object that would be returned in that error case. Now saying, does this email get sent? So the mock is the email service. Even if we haven't done this yet, we can say, can we assert that we can correctly identify that an email needs to be sent? Is that email actually being fired off? No, not necessarily. But can we say, yes, if we plugged this in here, this would at least analyze and say, yes, do this, whatever this happens to be. Then we could write some tests that assert, once we have the mock email sender, we can write some tests about that mock that says, is this mock performing as we would expect? If it is, then once we have all of this complete, it should be plug and play to the best of our knowledge. If not, there was an issue with the stub and box system, and we can find that out now, rather than once all of the development for the web service is complete, the email sender is complete, these tests are written about real values. You can write tests for the stub web service and how how this whole system works together without actually implementing very much of that system. And that's very useful for saving time when some other development team is behind. You need to start working on the tests for this. You don't want to wait for them to finish. You want to test and make sure your object is working. You can do this work, and it's not a ton of work, and there are libraries and frameworks out there to help you to do this process. Questions on stubs versus mocks, how they can work together, what you write the test for? Anything in that regard? That's basically the end of this slide deck. This is the last thing that was covered on the study guide for the quiz on Monday. So I will circle back now to, do people have any questions? This is all that I wanted to cover today. This is all of the requirements for the current sprint, for the current quiz. We'll start more fresh next week with new, like Tuesday of next week, there's some new, I guess, probably review content for some of you, but more applying it, because I want to go back through a lot of the design patterns that were covered. That's the direction that we're going to be going. And rather than just talking about how can we use these design patterns, or even making a project that are going to use some of these design patterns, the question is just, let's go kind of design pattern by design pattern and ask the question, how can we plug and play this into our project? Where could it go? What would it represent? What are the associated classes? What would this do for us? What are the benefits and detriments of incorporating this pattern to this project that we are making? And I think that will hopefully help chunks of 212 to click into place and sink in. So that's what we're going to start in on next week. But the next 18 minutes or so, I'd love to answer any questions people have about anything off the study guide. What do we got?
There's gonna be one question.
I would expect a similar proportion from quiz one. So there were a couple questions on quiz one that were from debugging teams. I would expect about that same amount.
So are we specifically looking only at chapter 3 with leadership, or are we also looking at chapter 4 with it as well?
Nothing in chapter 4 yet.
Oh.
Yeah, just chapters 2 and 3 for now. I think quiz 3 will probably cover 4 and 5. Then I don't remember exactly how I'm thinking about planning it out, but I'll have to go back and look at it. Other questions? Everything makes sense? Feel like you have a solid grasp on all of those topics on the study guide, even if it's just I don't understand much about this concept. Can you talk about it or go over it? I would love to be able to do that. What kinds of questions would you ask me? Would you ask about this topic? I can answer those kinds of questions.
What the difference from MVC and observer?
That is a great question. So observer, we're trying very hard to. So it's about a connection, basically, right? So we want to look at a particular connection and say we have an observer and we have something that is being observed, waiting for something to happen so that we get auto notified of certain things. So the observer pattern is about those notifications. And MVC is more about the associated triggers in the So an event happens and you want to mass send it out to everyone connected to this observer. Right, again, thinking about like the newspaper subscription example, there are a bunch of people subscribed to the newspaper. When the newspaper publishes something, it's throwing out newspapers to everyone who's subscribed to it. At that point, that would be a kind of controller connection. But MVC is really the difference between data, updating data, being able to swap out different views. So you would apply MVC to observer if there were different ways to acquire that newspaper. Maybe there's a paper subscription, maybe there's a web-based subscription. We have different views of ways to handle those same newspaper stories. That's where you need MVC on top of that to say, when someone puts in a request, I want to change my subscription from a physical subscription to a digital subscription. What happens? The controller would catch that, unsubscribe them from the observers or the observer for the paper subscription and subscribe them to the service for the digital subscription. So that might be how they would connect to each other and how they would be separate. So a lot of design patterns go really well together like that. MVC and observer do go really well like that, but there are distinctions to the components of one and the other. Does that make sense?
Yes, we see pretty much like when your data comes in and out, it controls that and then feeds to and connect to the server like to multiple different ways. Also, it can also
Right.
use the internal view, a similar function.
Yeah. Yeah. Great question. Not on the quiz, in case anyone was trying to think, wait, is this on the quiz? No.
Bonus question.
We'll cover more about design patterns next week, but. Anything else? Anyone else with questions? I'm gonna give people a little bit of time to bring up the study guide, look at it, find questions. Yeah,
Like verification versus validation.
yeah. Yeah, so. Code verification is going to assume that let me bring up the slides, because I want to talk about exactly how the slides were done. What was that under? People remember the exact slide deck. I'll quickly go find it. Which one is it in the, what's the subject that is under in the study guide?
Testings.
Yeah. What's gonna be in the testing overview slides? The way that I wanna talk about it is directly off of I'll try to expand upon what's here. So we talked about verification and validation in this sense. So validation is prevention of building the wrong product. We want to make sure we're building the right product by making sure we're not building the wrong product. So everything that we do in the validation is done in the earlier stages of the development timeline. Things like specification and design are oriented to preventing you from building a product the client is not going to want, or is not what the client asked for. Verification is more of the kinds of unit tests that you would write that says, is the product constructed in a way, even if the specification is good, if the product doesn't meet the specifications, then that's a verification issue. So kind of the planning process and the building process. Are the issues with the plans? If so, that's validation. Are the issues with the implementation? That's the verification. So we talked about validation being. So we're going in the opposite direction here. So validation is the prevention. So code walkthroughs, inspections, audit standards, the reviews and meetings that we use to look at the specification documents, the design plans, the requirements and specifications. Those are all validation techniques. And then the verification techniques are the actual testing techniques that we talked about. So every testing technique. Clarification questions on that? Does that answer the question? Follow-ups, other questions? Yeah,
Are we expected to know the various verification techniques?
I would say if you were able to say something like all kinds of testing, you would be right for that scope of that question. It said, what are verification techniques? It's not asking you what are all of the different types of testing. But because testing is also on the quiz, I might ask you to list and describe 3 or 4 of those. What are they? How do you write that test? When is the appropriate time to write that test? So you would need to know that, but depending on the wording of the question, I might or might not be expecting them associated with this verification techniques idea. What else? The awkward stare, the professor who knows people don't know everything and the students who think they know everything. Okay.
Are we allowed to bring like a piece of paper like last time?
Yes.
Okay.
Yes, for every quiz, you are allowed a different piece of paper. You don't have to bring the same one as last time. It doesn't have to have the same. Make a new sheet with new information. Fill that with whatever you want. Again, I'm not trying to quiz you on definitions. So if you wanted to write down all of these under verification, please do. Because you could easily Google, what are verification techniques in computer science? Bam, here's this list. I don't want you to memorize that. I want you to link the idea behind what are these tests with deeper level than that. Yeah,
So with debugging teams chapter 2 and chapter 3, these kind of a hint, like say any certain parts we should probably refresh ourselves on, or
I just go skim the whole thing again, just to see. The kinds of questions that I will try to ask about that will be either critical thinking, your own experience with tying any of those ideas to concepts that we've covered in the class. Those are my favorite kinds of questions to try to ask. Link these ideas together. You studied one in a book that somebody else wrote. You studied another in a lecture setting. You experienced another in your projects. The experience you had with your project. Try to tie all of this together. In some sense, it is all related to each other.
Quickly go over static versus dynamic testing.
Yeah, so. Is that in this slide deck? I feel like it might not have been. If it's not, then it's not gonna be on the quiz. If I put that on there, I might have thought I was gonna go over another slide deck that I ended up cutting. But I can talk about it, but I also don't remember lecturing.
The good old control.
Yeah, no, I know it's not in here. I know it's not in here. And I don't think it was something that I skipped over in here. Definitely did not. Sorry. I would say don't worry about static and dynamic tests. I put these on study guides and sometimes I reuse significant chunks of them. And if I actually show you the sets of slides that I've been going over, there are actually 2 more sets of testing slides that I did not go over. The actual unit testing, because we covered unit testing in past classes and black and white box testing in more detail because I feel like we've covered it in enough detail. I will upload these extra slide decks in case you're curious about it. But that's probably something left over from the last time that I taught the class. That was a slide deck that we covered at that time. I apologize, there will not be a quick question on static and dynamic tests. Five more minutes of awkward staring at each other, or if we all vote for it, we can leave 5 minutes early and give you a chance to talk to your teams.
I don't really like my team all that much.
I'm gonna talk about these
If
chairs.
I have to talk to them, they're just gonna make me do work. So,
Better come up with some questions really quick then.
Avoid it like your mom, you avoid the unskippable side quiz.
If people have extra questions or think of extra questions, I'll be in my office for, I don't know. At the very least an hour, probably 2 or 3 of them. So feel free to come swing by and ask your individual question, otherwise. Have a good weekend. Get lots done. Reach out to me if needed. I have now unfortunately muted your discords, so if you need me for anything, please ping me. I'm not doing a daily pass over everything.
I see it.
Yeah, and every single message that everyone sent in any of those channels buzzed my phone. All of that communication happening between 8 PM and 12 AM.
Your family's like, why can't we get a hold of you?
Right.
Here.
It was important to me to make sure that everyone was on the right track, so that was very important.
I know.
After the first sprint, saying, now that you need me, please reach out to me. I'm still here, but I'm not looking for
You know.
problems that you need on a daily basis. Like, I want to start there.
Oh, it's so cute.
I'm gonna need you in my life.
All right, thanks, everyone.